Hi, I'm Whitney, and today I will be showing you how to solve systems of equations by elimination and substitution. I hope you enjoy.
A system of equations is a set of at least two equations in the same variables that are considered or solved together. To solve a system of equations, you must find a solution that will make both equations true. Systems can either be solved graphically or algebraically. Solving a system of equations graphically depends on two things: that the lines intersect and that you can actually read the point where they cross. Unless an intersection has integer coordinates, it can be a bit difficult to tell what the solutions are. That's why knowing how to solve systems algebraically is so important. When we solve systems algebraically, we can use one of two methods: substitution or elimination. When you have two equations in two variables, the goal is to get a solution that will satisfy both equations. The only problem is that you have two variables. One method is to solve one equation for y, substitute that value in the other equation, and simplify to get the value of x. Then, use the value of x in one of the equations to get the value of y. This method is called substitution. Let's try to solve the following problems using the substitution method. The question is, what are the coordinates of intersection for the lines 2x minus y equals 5 and x plus y equals 4? The first thing we would do is put one equation in slope-intercept form. Let's use the second equation because it only has ones for coefficients of the variables. This makes it easier to put the equation in slope-intercept form. Now let's substitute the y value into the first equation and simplify. Start by removing the parentheses. You can do that by multiplying the contents by -1. Combine like terms and add the opposite of -4 to both sides. Then, divide both sides by 3 to get a value for x. Now substitute the value of x into the second equation and solve for y. The solution of the system is 3 and 1. You can check the solution by replacing the variables in both equations to see if they make both equations true. As I mentioned earlier, a second way to solve systems algebraically is by elimination. With the elimination method, we have to combine the two equations in such a way that one of the variables is eliminated. We've already solved the system by substitution. Let's do elimination with the same system this time and see what happens. When solving a system of equations by the elimination method, look for a way to make one variable's coefficients opposites. Take a careful look at the two equations. Notice that there is a plus y in one and a minus y in the other. If you add the two equations together, the y's disappear. Now that the y's are gone, you can solve for the value of x. Use the value of x in one of the formulas to find y. Notice that those are the same values we got when we used substitution. This was an easy one because you didn't have to do anything to the equations to eliminate one of the variables, except to add them. What happens when they're not so convenient? You have to do something to one of the equations to make a variable disappear when you add them together. Remember that you can do anything to an equation as long as you can do it to both sides. It doesn't matter which variable you eliminate or which equation you modify. Just look for the one that will be easier to modify and pick an operation to make it work. It may even take a combination of operations. The goal is to eliminate a variable and solve for the other one.
That's it for this video. I'll see you next time.
That was really good.
Hello.
I love that. I feel like I see in her eyebrows.
Right, they went up So now we just need to do a close and then you'll be good.